Hi, today I am going to talk about upside down division. Upside down division is something that can be used to find common denominators. It can be used for prime factorization. It can be used for greatest common factor or least common multiple. There's all different sorts of variations you can use this for, but today I'm going to work with a greatest common factor. So when I'm asked for the greatest common factor of 12 and 18, I'm looking for the largest number that goes into both 12 and 18. I'm using two numbers that are fairly small so you can kind of get a general idea. What I do is I draw an upside down division box and I place both the 12 and the 18 inside the division box. I'm going to list a few prime numbers here that will help me as we are going through knowing whether there's more factors that divide in or not. These are the first 10 prime numbers. Now, when I'm looking at my upside down division, as a practice, because I typically do greatest common factor, least common multiple, common prime factorization, common denominators, I do all of these things with upside down division. I just follow the same process every time. And I look to see if the first prime number goes into the two numbers I'm dealing with. Because 12 and 18 are even, 2 is going to divide into both of those. So I put 2 on the outside, and then I write however many times 2 goes into 12 below 12, and however many times 2 goes into 18 below 18. 12 divided by 2 is 6, and 18 divided by 2 is 9. And then I draw another box, and I go back to the beginning. I ask whether 2 is going to go into 6 and 9. But because 9 is not even, 2 is not going to go into it. So then I go on to the next largest prime number, which is 3. 3 goes into 6 and 9, so I'm going to put 3 on the outside. 6 divided by 3 is 2. 9 divided by 3 is 3. Once I get down to this point where I have 2 and 3, which are both prime numbers, and there is nothing else that divides into 2 and 3 evenly, I find my GCF, which is the product of the numbers on the outside. So the GCF is equal to 2 times 3, which is 6, because 6 is the largest factor that goes into 12 and 18. I can use upside down division with more than two numbers, and I can also use it with variables. So for instance, if I had 15 x squared, 20 x to the third y, and 45 x squared y. I'm going to deal with the numbers first. And again, I'm going to try 2 and see if that works with all of the numbers. 15 is not even, so 2 is not going to go into that. 15 is divisible by 3. I check 20. 20 is not divisible by 3, so I have to move on. 5. 15 is divisible by 5. 20 is divisible by 5, and 45 is divisible by 5. So I put 5 on the outside. 15x squared divided by 5 is 3x squared. I deal with the coefficients and then I drop the variable down as well. 20 divided by 5 is 4, and I still have x cubed y. 45 divided by 5 is 9, and I still have x squared y. And I go again. Looking at my numbers, 3 and 4 don't share anything in common. Even though 3 and 9 do, when I'm looking for the greatest common factor, it has to be common to all three. So I have no more numbers that are common to 3, 4, and 9. They're relatively prime together. But if you notice, each term has an x component. And so I can take out an x. And what I'm doing is I'm actually taking out the most number of x's that are common to all three. This is a second power. Second term has 3. Third term has 2. So between 2, 3, and 2, the maximum number that is shared by all three is 2. So I'm going to take out x squared. 3x squared divided by x squared leaves me with 3. I leave the 4. X cubed, I take 2 out, leaves me with x, y. 9, I take out the x squared, I'm left with y. And so I know that I found my greatest common factor when I look at my remaining pieces and see that there is nothing common to all three of them. So multiplying the numbers on the side to get 5x squared, that is my GCF for this problem. Thank you for watching.